All right, so today we're going to talk about what are called double angle identities, right? And so the idea is we know that cosine of, say, 30 degrees is radical 3 over 2, right? What if we wanted to just double the angle, right? So cosine of 60, right? It would make sense that if we double the angle, just double the value, right? So radical 3 over 2 times 2. Well, when you do that, you just get radical 3. But the question is cosine of 60 just radical 3? And the answer is no. So it's not quite that simple when it comes to doubling the angle and coming up with sine, cosine, and tangent values, right? So the question is, all right, well, how do you do that? If you need to double an angle or whatever, what values would you get? And that's where these guys come into play. Right, so these are your double angle identities. If you're going to double an angle measure to find sine, cosine, and tangent values, you have to use these formulas. If you look, some of these formulas look kind of familiar. This guy right here, the first cosine, double angle cosine formula, looks a little bit like the Pythagorean identity. You also notice that there are 3 different cosine double angle formulas. And really, which one you use doesn't matter. Some of it depends on just the information that you have. If you notice, in all of these, in all of the sine and cosine, or 2 of the sine and cosine double angle formulas, you've got to know both sine and cosine of the original angle. With these 2 cosine double angle formulas, you only have to know either cosine or sine. So it requires less information, requires less work. Okay, but bottom line is we got to know the formulas, or at least be familiar with them enough to work with them. Right? So how does this all work? Right, let's just jump into a problem. So if we know that the cosine of an angle is 3 over 5, and yeah, we don't have to stay in the unit circle, we don't have to stay with special angles, it can be for any angle, these work for any angle. Right? If cosine of an angle is 3 over 5, we want to be able to find out what sine, cosine, and tangent values are if we double that angle, whatever it is. We don't even care what it is. Just double it. Right? Well, the sine, the double angle sine formula says that we got to take 2 times sine of the angle times cosine of the angle. Well, we got cosine of the angle, we just don't have sine. So we got to figure out sine. Well, we did this last homework where we drew right triangles and we put in side lengths and we tried to come up with the third side length and put together what sine is. But can we make this a little bit easier? Do you remember that cosine is x over r in terms of coordinates of the unit circle and the radius of the unit circle? Do you remember that sine is y over r? And do you remember, and I'll write this over here, sine of x is just going to be y over r, and tangent is just going to be y over x. Because if we know that, then we can get into our equation of a unit circle, x squared plus y squared equals r squared, to find all the values that we need. Right? If cosine is x over r, that means x is 3, so we take 3 squared plus y squared equals, and then r is 5, so 5 squared. 3 get 9, plus y squared equals 25. Subtract 9 from both sides, we get y squared equals 16. Square root both sides, and y ends up being 4. So that means that sine of x is going to be y over r, or 4 over 5. Now, careful, because we have to figure out positive or negative next. And this says that sine is less than 0, so this is going to be negative 4. So now we have the cosine and sine of that angle, the original angle. That helps us find 2 times that angle by using this formula. 2 times sine of x is negative 4 over 5. Cosine of x is 3 over 5. And now just multiply it out. Make this 2 over 1. Take 2 times negative 4 times 3, which is negative 24. 5 times 5 is 25. And that's it. That means that sine of twice that angle is negative 24 over 25. Okay? Now, double angle cosine. Now that we have sine and cosine both, it doesn't matter which formula that we use. But before we went and found sine, if we had just known cosine, there was one formula that we were going to need to use. Okay? But since we have both of them, we can use whatever we want. And I'll go ahead and just use that first one. So we've got to take the cosine of the angle and square it, subtract sine of the angle after it's been squared. So cosine squared minus sine squared. So we got to take 3 over 5 squared minus negative 4 over 5 squared. So we go 9 over 25 minus 16 over 25. Subtract that out, we get negative 7 over 25. Okay, so that's the cosine of twice that angle. Tangent, the formula is the same no matter what, so we've got to take 2 times tangent of x over 1 minus tangent squared. And now just write in the value. Tangent is supposed to be y over x. So we come up here and we make tangent of x. Y is 4, x is 3. Can't really see that. 4 over 3, but watch your signs. Cosine is positive, sine is negative, so that means tangent has to be negative as well. So negative 4 over 3. So now we come back into our formula. So 2 times negative 4 over 3 all over 1 minus negative 4 over 3 squared. So we get negative 8 over 3 over 1 minus 16 over 9. All right, so negative 8 over 3 over, now 1 minus 16 over 9 requires us to get a common denominator for the 1. So we go 9 over 9 minus 16 over 9. So we get negative 8 over 3 all over negative 7 over 9. Now we wanted to flip and multiply by the reciprocal. Reduce here. So 3 goes into 3 once, into 9 3 times. So we get negative 24 over negative 7, which is just 24 over 7. Okay? And so there's the use of all 3 formulas. Everything else is going to stay the same. It's just being able to do the arithmetic. Okay? So let's try another one, and then I'll turn you loose on one. All right, so the next one. We've got, we know that sine of the angle is 8 over 17, and we want to find sine of twice the angle, cosine twice the angle, tangent twice the angle. So sine is y over r. We already know that we're going to have sine and cosine both. So just put that in to the equation of a circle to find out what x is, and we can figure out cosine from there. So x squared is going to be equal to, that's going to be 225, square root both sides, x is 15. So that means that cosine of x is going to be 15 over 17. We look over here and see that cosine is negative, so this value has to be negative. And we've got to have tangent, so tangent of x is going to be y over x, which is 8 over 15. And if sine is positive, cosine is negative, that means tangent has to be negative also. Right? And we get into our formulas. So 2 sine x cosine of x. So 2 times 8 over 17. And then, negative 15 over 17. Okay? Put that over 1. Multiply it out, we get negative 240 over 289. And I don't think that will reduce, so we'll leave it there. Okay? Cosine, again, you've got 3 formulas, any of which would work. We were given sine, so I want to use the sine formula, the one that has the sine in it, just in case I screwed up the cosine part. Plus, this gives me an opportunity to just do a different formula. So 1 minus 2 times 8 over 17 squared, right? So So 1 minus 2 times 64 over 289. Multiply the 2 into the numerator, you get 128 over 289. Now you got to get common denominators. So 289 over 289 minus 128 over 289, which we get when we multiply this guy top and bottom by 289. Subtract that, you get 161 over 289. And don't think that that will reduce either, so we're done with that guy. Next, tangent. The formula is 2 times tangent of x over, go 1 minus tangent squared x. So, tangent we know is negative 8 over 15, so just fill that in. So 1 minus negative 8 over 15 and square that in the denominator. So we get negative 16 over 15 over 1 minus 64 over 225. So negative 16 over 15 over, getting the common denominator here, would get us 225 over 225 minus 64 over 225. Right, which is 161 over 225. Flip and multiply. 161 over 225. Wait, flip and multiply. It's actually 225 over 161. That's going to be 1. This is going to be 15. So we get negative 240 over 161. Again, that won't reduce, and so we're done there. Whew. A little bit of work, but we got this. Okay? All right. Another one. And this is where they give you tangent. So you're going to have to know that, use the fact that tangent is y over x, and then go find r, right? So x squared plus y squared equals r squared, and I know that because, and I'm doing this because, again, I have to find out what sine and cosine are, and I can't do that without r. So go 3 squared plus 5 squared equals r squared. We've got 9 plus 25, so this is going to end up being the square root of 34. That means that sine of the angle is 5 over radical 34. Cosine of the angle is 3 over the square root of 34. This says that sine is negative, so if I'm going to make that negative. Well, if tangent's going to be positive, that means cosine has to be negative as well. Okay? Now, my suggestion to you here is just to leave the radical 34 in the denominator. Don't worry about rationalizing yet. We may not have to once we do all the arithmetic, right? So we get into our formulas. 2 times sine of x cosine of x has us taking 2 times negative 5 over radical 34 times negative 3 over radical 34. And so this is what I mean, right? When you multiply this out, you get positive 15, positive 30. Radical 34 times radical 34, remember that when you multiply two radicals that are the same, the radical just drops and you just get 34. And so we don't have to worry about rationalizing, at least not with sine. Okay? Cosine, you know all values, so it doesn't matter which one you use, which formula you use. So whatever. I'm going to use the cosine squared minus the sine squared one. So cosine is negative 3 over radical 34 squared minus negative 5 over radical 34 squared. So we get 9 over 34. Remember, when you square a square root, they cancel each other out, and you just get whatever's inside the radical. And then 25 over 34. Then we can subtract and get negative 16 over 34, which is just negative 8 over 17. And that's your cosine of twice the angle. And then tangent. Tangent is 2 times tangent of the angle over 1 minus tangent squared. Tangent was given to us. So tangent is 5 over 3. We take 2 times 5 over 3 over 1 minus 5 over 3 squared. So we get 10 over 3 over 1 minus 25 over 9. Get a common denominator for that 1. And we get 9 over 9 minus 25 over 9, which gives us 10 over 3 over negative 16 over 9. We're going to flip and multiply. Now reduce. That's a 1, that's a 3. This is a 5, this is an 8. 5 times negative 3 is negative 15. 1 times 8 is 8. And we're done. Okay? So just working through, and none of these did we end up having to rationalize the denominator. So just leave it alone until you have to rationalize. Okay? Now, we can actually work our way backwards. If we have the double angle value, we can use the cosine double angle formulas to get us back into our single angle values. All right, so for example, cosine, the double angle value is 4 over 5, which means I can't use x over r to find the single angles. It's just a different angle measure, so they're not going to match up. Instead, though, we do have 3 formulas for cosine, for the double angle cosine, 2 of which have just a sine in it and just a cosine in it. In other words, I can use this cosine 2x equals 1 minus 2 sine squared x. Because I know what cosine of 2x is, which is 4 over 5. Now I have an equation that I can just solve for sine squared x and then square root both sides. So to do that, I would subtract 1 here, which means getting a common denominator, so 5 over 5, right? So we get 9 over 5 equals negative 2 sine squared x. Now divide by negative 2, making that over 1, flip and multiply. So we get 9 over negative 10. Oops, I messed up. 4 over 5 minus 5 over 5 does not give you 9 over 5. It gives you negative 1 over 5. So that would be negative 1 over negative 10, which is going to be 1 over 10. And now we can square root both sides here and find out that the sine of the original angle was 1 over radical 10. And I'm going to leave that unrationalized just for right now. Okay? Now, how does that help? Well, if sine of x is 1 over radical 10, now that gives me a glimpse into y and r for the single angle. So x squared plus y squared equals r squared. It will help me find cosine and tangent, right? So I go x squared plus 1 squared equals radical 10 squared. So x squared plus 1 equals 10. Subtract 1, x squared equals 9. And then square root, and x ends up being 3. So now I can go through and figure out all of my values. So the angle is between 90 and 180, which means that we're in quadrant 2. So if we're in quadrant 2, that means sine is going to be positive. So sine of x is going to be 1 over the square root of 10, or to rationalize that would give you radical 10 over 10. Cosine needs to be x over r, right? So x is 3, r is radical 10. Again, we're in quadrant 2, so this has to be negative. So now if you want to rationalize, we don't even have to use a formula, right? And then for tangent, it's it's y over x, so it's just going to be 1 over 3. And again, we're in quadrant 2, so the tangent's going to have to be negative. So it's actually a bit easier once you find one of the single angle values. You can just use that in your x squared plus y squared equals r squared to find the other two. Now, you could have just as easily found cosine of x first using the other formula, the double angle formula that has just cosine in it. Maybe we can look at that. Okay? So, for example, this guy. If I know that the double angle cosine is negative 12 over 13, I can always find cosine first, because cosine of 2x, there's a formula that says 2 cosine squared x minus 1 is equal to that. So this is negative 12 over 13. And now I can just solve for cosine squared and square root. So add 1. Got to make this a common denominator, so 13 over 13, which is going to give you 1 over 13. Right, now divide by 2. Flip it over and multiply. You get 1 over 26 equals cosine squared x. Now square root. And cosine x is going to be 1 over the square root of 26. And we'll rationalize in just a second. Okay? Now, your angle measure is between 180 and 270, which means that we're in quadrant 3. If we're in quadrant 3, then cosine has to be negative. Actually, just for this purposes, I know that I'm not going to have to, I'm just going to go ahead and rationalize it. Makes me feel better. It's not going to get me in trouble later, so it's square root of 26 over 26, negative. But that means I've got my x and my r now. So this is x, this is r. So I can come up here and say x squared plus y squared equals r squared, where x is 1, y we don't know, r is the square root of 26, and square that. Remember, when you square a square root, you just get whatever's inside. So y squared is equal to 25. Now we're going to square root, and so y is 5, which means that sine is 5 over the square root of 26. We're in quadrant 3, so it's got to be negative, and then we can rationalize. No problem. Tangent is y over x, so it's going to be 5 over 1. And again, we're in quadrant 3, so it's going to be positive, so this is just going to be 5. Cool, and that's it. Now, we can use these double angle formulas to help us verify some trig identities if we want. Okay, so let's take a look at how we might be able to use these double angles to help us out. Bell's going to ring in a second, but we're going to fight right through it. All right, left side, right side. I'm going to choose to rework the left side. So sine, double angle sine means that I can rewrite this as cotangent x times 2 sine x cosine x. Okay? Now, cotangent I can rewrite as cosine over sine. Then let's multiply those out, right? So if I do that, I can divide out the signs, and we get 2 cosine x. Now, what's going to be weird is 2 cosine squared x is part of one of your cosine double angle formulas. it comes from the one that looks like this. But apparently what we've done is we've just added 1 to both sides to get cosine, well, write the 1 first. 1 plus cosine 2a, and then this is 2 cosine squared a. So what that means is I can take this and replace that into there. So I can go 1 plus cosine 2x equals 1 plus cosine 2x. So like those Pythagorean identities, we can move these formulas around a little bit. Okay? All right, let's try another one. I'm going to rework the left side for sure. Okay, if I do that, cotangent to the 4th, I can rewrite as cosine to the 4th over sine to the 4th times sine squared x, right? Divide these out, means I'm going to be left with cosine to the 4th over sine squared. Looking for this to be cosine 2x, right?